Okay, so let's go through an entire hypothesis test. We want to test the claim that the proportion of people who own cats is larger than 80% at the 0.10 significance level. All right, so this is telling us immediately what our alternate hypothesis is. The word proportion tells us we're going to have P, and the people who own cats is larger than 80%. We'll always have this 80% expressed as a decimal, so we're looking for 0.8, and larger than tells us the alternate is going to be a greater than. So let's look for P greater than 0.8 in our alternate hypothesis. Okay, so that is going to be this one right here, P greater than 0.8. 0.10 is our alpha. That's our significance level. So we'll just keep that in mind for later. All right, so since the alternate is a greater than, it is a one-tailed test, and it's pointing to the right, so it's a right-tailed test. Okay. Based on the sample of 700 people, 84% owned cats. Now let's notice this is asking for the p-value, but before we can find a p-value, we always have to find a test statistic. And we did a test statistic example in one of the prior videos, but let's do our test statistic for this one. And I can pull up the document we had. There is our calculation for the test statistic. There's our formula. So let's go ahead and start that formula. Let me put some space here. All right, so we had P hat in the question. Let's go back. P hat is 84% owned cats. Now, as a decimal, so that's 0.84. So on the top, we'll have 0.84 minus our p-value, or not our p-value, but our value for P, which I believe was 0.8. So that's right here. Yes, it's 0.8. Divided by the square root. Now we're going to have 0.81 minus 0.8, and on the bottom is our sample size, which I believe was 700, but let's look back. Yes, 700 people. So 700. Okay, so let's work this out, starting with the top. On the top, 0.84 minus 0.8 is going to give us 0.04. Before I do any of the square root, I want to go ahead and subtract 1 minus 0.8, which is 0.2. And now I can do the entire bottom in my calculator. The square root of 0.8 times 0.2 divided by 700. And that gives me 0.015119. And I'll go ahead and do that last division, 0.04 divided by that number. And we get 2.645678. And let me just double check as I said that. I might have 5,678. Okay. Now let's put that into Excel to get our p-value. Now let's go back to our alternate for a minute. Our alternate was a greater than. So once we get the value from Excel, to get our p-value for a greater than, we have to subtract it from 1. So let's go ahead, and I'm just going to bring this back up so we'll have it side by side as we look at Excel. Pull this over a little bit. I want to put in equal norm.s.dist 2.645678, oops, and true, and that gives me that thing, which I'll copy and paste because I still have to subtract it from 1. So my p-value is equal to 1 minus what I just copied. There it is. And let's put that thing into our calculator. And that gives us 0.004076. Now I'm betting that we need to round our p-value to 4 decimal places, which will make this 0.0041. Let's go back and see. Oh, 2 decimal places. Okay, so if we round 2 decimal places, oops, back here, That's going to be 0.00. All right, so let's put in 0.00. All right, so certainly 0.00 is smaller than our alpha, 0.10. And remember that if the p-value is smaller than alpha, we reject the null hypothesis. All right, that does it.